So for the next video we have to do the separation of the insole, and so you can keep in mind what we have done in the first video. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sensors in the toe region. The next one are for the forefoot, and the next one for the midfoot, and the next one for the rear foot or heel section. And you can think it as columns in your measurement data. We can see it in here in MATLAB. When we're opening the data, we can see, okay, the first one is the first sensor, and so on and so on. And we have to take out these specific columns for every region. And this is what we are including now in our code. We are making a new section break and define some variables. So we have a toes variable which gets the data from data, but what specific part from data? We now take the interpolated data in this case, so not data. We take this one because it's now interpolated. And from this interpolated data, we only choose a specific amount of columns. And the amount of columns is, as I told you, from 1 to 13. So I take all information, so all rows in the column 1 to 13. And these are the values for the toe regions. So, okay, I run this section and I should get these 13 columns. So, because it's interpolated, I have 1000 rows and 13 columns, so that's perfect. And I can do the same for the forefoot region. And the forefoot region gets the values from the next columns. I've looked it up in the sensor data file. So you have to choose these values from your insole size, because as I told you in the first video, the amount of sensors differs due to the larger or smaller insoles. And then I take it from 14 to 79. I want to copy the whole one out. Then I have the midfoot from the interpolated data. And probably you should see how it works now. So from column 80 to 122 in this case. And then one is missing, so the heel section goes up from 123 to 157, and that's the heel region. So I run this section to see if the data is in. So no error message, that looks good. And now I can work further with this variable. So what is to do now with these variables? I take a mean out of it, mean of the toes, to see what happens in the toe section. Toes equals to mean toes. and I make a new figure. And plot this mean toes. Save and run the section. And I get nothing back, and when I get nothing back, I look into the variables for mean toes, what's in there. Okay, looks pretty ungood. Because you have to keep in mind the dimension, and by including the other dimension we run the section, and now we get a better result. And as we know from GAIT analysis, the toes are the last part which is included in the stance phase during the toe off. We can see also the pressure in the toe off in the single sensor data, but now this is for the whole region, the mean of this area, and now we can calculate that for all other sections. So I copy that one 4 times, and I make it for the forefoot, for the midfoot, for the heel. So I could have made it and the forefoot is missing. Okay, now we have all of these 4 variables, and now we plot in the same plot, and we switch hold on, so we can plot in the same plot on this side, and then we plot the new generated data, so the mean underscore forefoot, then the hold stands for the whole plotting procedure, otherwise you have to switch hold off when you want to get a new window or overwrite it. And we take plot midfoot, and one is missing, so the heel section. We save it and run the section, and now we should get at least 4 lines in there. We are getting pretty much in there. Okay, what happens? Let's look up. I have used mean toes, forefoot, midfoot, heel. Okay, it looks that way because I didn't include the mean value in here, so we have the single sensors, and we run the section again, and perfect. We see the sum of the zones from one measurement from one stance phase, and now see this result. Good. At this point we have to do that for the other stance phases as well, so we can do it in different ways. We can write it down, start 2, start 3, and so on till the end. The same with the end 1 to end 10, or we can write a for loop to automate this. And when we have done this, we have data for all of these stance phases. We can build out the mean of the single zones, and due to that we can plot the mean and the standard deviation.